Okay, we're looking at slope, doing some calculations of the rise over the run. So in the try these, it's just, again, some practice with integers because we will need to use integers. So remember, when you're subtracting a negative, it's the same as adding. So -3 plus 6. So if you think of a number line, you're at -3 and you're going to the right 6. You're going to be at +3. Here, subtracting a negative is adding, so 5 plus 4 is 9. Here, just one operation. So 1 minus 7, so a number line. If we're at 1 and we're going to have to go to the left 7, so we'll be at -6. And then -2 minus 10, same thing at -2. We're going to go to the left 10, so we'll be at -12. Okay, let's get into some of the slope stuff. It says Louise is traveling in British Columbia. She knows that 7% on this sign, so you can see the sign here, refers to the slope or grade of the hill, so that trucks know, cars know how steep it is. For every 100 meters of horizontal distance, the elevation increases by 7 meters. Okay. How are the grade and slope related? So it's going to take us through step by step. But this here shows a diagram. So here's the road. Okay. It's on an uphill or a downhill, depending on which way you're going, obviously. And so for every 100 meters horizontally, the rise is 7 meters high. Okay, and so the grade is 7%. Grades are usually given as a percent, and slopes are usually given as a fraction or a decimal. So write the grade as a fraction in lowest terms. So 7%, remember, is 7 divided by 100. Write the slope as a ratio and as a decimal. So slope is rise over run. So you have to memorize that. It's over here again if you need to. Rise is the change in the vertical, change in y, and run is the change in the horizontal, or x. Slope as a ratio, the rise is 7, the run is 100. As a decimal, that's 0.07. Okay, so which as a percent is 7%. Right, so these are the same. The grade and the slope are the same, just a different way of representing it. Typically, grades we use for building, construction, roads, ramps, that kind of thing, and they're usually shown as a percent. So suppose the road had a rise of 8 meters and a run of 100. What would the slope be? So your rise is 8, your run is 100. So we can reduce that to lowest terms. 4 goes into both. So 2/25 is often how we show the slope, but in decimal form, we can go right from 8/100ths to get 0.08. Okay, and then slope, we can take that fraction, 8 over 100, and multiply by 100 to get 8%, or you can multiply this by 100. So slope as a decimal, 0.08. As the grade then is 8%. Okay, so you can see here it also points out, as I said, grade is a slope expressed as a percent. Another word for slope is pitch. That's often used in building as well for roofs of a house or building, typically. So Zenaida is a contract developer. She's building a set of 5 steps. Each step must have a 6-inch rise height and a 10-inch tread depth. So we're doing the steps like this. 6-inch rise here, 10-inch tread. The tread's on the step. Okay. What is the pitch of each step? Which means the slope, but in building it's sometimes called the pitch. How does this compare to the pitch of the whole staircase? And is the staircase constant? Well, yeah, I mean, it's going to be obvious. We haven't been told that it's going to be any other steps of any other rise or tread, So it should be constant and it should be the same, but we'll do the calculations. So there's diagram for it. What is the pitch? So the rise, remember, is 6, and the tread, the run, is 10. That reduces to 3/5, or as a decimal, 0.6. What is the pitch of the whole staircase? Well, we've got 5 steps, so 5 times 6 and 5 times 10, so that's 30/50, which again reduces to 3/5, or 0.6. So the pitch of each step and the pitch of the staircase are equal. And it's 0.6 if we use decimals. Kind of depends. If it's going to end up being a decimal that you want to round, then you really want to keep it as a fraction. So if it's going to be a repeating decimal, then you should keep it as a fraction for sure. But for applications, we often use decimals. So Marcia is a carpenter. She drew a plan for the roof of a house on grid paper. What is the slope of each side of the roof? How do the slopes compare? So you'll notice she used an x-axis and a y-axis. She's plotted some points here. Okay, what is the slope of the left side? So count the squares from the rise. So basically we want to find the rise from 4,3 to 10,7. So we want to go up here and to the right. So always rise over run. So always go left to right on your diagram. And so the rise here is 4 and the run is 6 if you count the boxes. So the rise is 4, the run is 6. So 4/6, which reduces to 2/3. Now, using the coordinates, we're kind of leading up to this slope formula. So the slope formula is taking 1 point, well, taking 2 points, subtracting the y values in the numerator and dividing by the subtraction of the x values. But you have to keep the points consistent. So the second point minus the first point, whether it's the x or y value. And it doesn't matter which you choose as your second or first point. So use the coordinates. What is the slope of the left side? So your y value here, if we call this the second point, is 7, and we'll subtract the y value of our first point, 3. So that's 4. And then our x value of our second is 10. Subtract our x value of our first is 4. So we're always going from that second point, and that's 6. So you can see here the difference between the y coordinates is the rise and the x coordinates is the run. And we get 4/6, which is 2/3. Now, if we do the same for the right-hand side, we have our 2 points here. And so our workbook has chosen this to be our second point. Even though it's on the left, it doesn't matter, and this is our first point. So our y value of our second point is 7, and our y value of our first point is 1. So 7 minus 1, and then consistent, 10 minus 19. So 7 minus 1 is 6, 10 minus 19 is -9. So we'd like to keep the negative out front and then reduce that, that's 2/3. So notice how there's some similarities. What are the slopes? How are the slopes the same? So the rise and run are the same. Okay, so therefore same pitch. It's just that this right-hand side is negative. And typically in application, we won't even consider that to be negative if it's not on a grid. But this is on a grid, so we have to keep that negative there. And so on the next page here, it says, how are the slopes different? Opposite, they are opposite in sign. sign, which means they meet and go in opposite directions. Not quite sure how to say that. Okay, because they meet at the top, right? At the top of the pitch there. Okay, so that's the end of section 6.1, and you can head on to 6.2 once you've done the practice. Make sure to do the practice first.